All right, so guys, today we're going to talk about two kind of special kinds of limits. So infinite limits and limits at infinity. So they sound very similar, but they are two different things. So we're going to kind of compare and contrast the behavior of functions as they approach infinity, and then as well as things that happen towards infinity, meaning their end behavior. Okay, so on the first example, and I'm going to kind of go back and forth between these two graphs. So we're going to look at f of x and g of x at the top. So the layout's a little bit confusing. But on the first one, I gave you the function, but we're specifically looking just at the graph. So the first question says the limit as x approaches 4 from the left on f of x. So I'm looking at this top graph right here. So you guys can see at this point, right, as it's approaching 4 from the left, it's what we call an unbounded behavior, which means it's approaching infinity. And as I'm looking at f of x as it's approaching 4 from the right, again, unbounded behavior, but in this case, it's approaching negative infinity. Okay, and then on g of x, I'm actually going to look at one from the left and one from the right. So if you guys look down here, as it's approaching one from the left, it goes down, right? So that's a negative infinity. And one from the right, again, that unbounded behavior upwards, so positive infinity. Right? So as you guys notice, right, on these, you should have been able to recognize this part of the graph, right? You guys have kind of seen those since Algebra 1. Those are a vertical asymptote. So what we can conclude in kind of relating that to limits is that a vertical asymptote will occur, okay, if one-sided limit or limits are unbounded. Okay, and remember that unbounded just is a very mathematical way of saying that it's going to approach infinity. Okay, so when we refer to something as an infinite limit, right, that means as x approaches c, the limit, okay, will approach either positive or negative infinity. Okay. So anytime we see a limit approaching positive or negative infinity, that should tell you that that's going to be a vertical asymptote in the graph. Okay. Now what could also happen is if you guys look down here, okay, notice the difference in notation. Now I'm asking what is happening to this graph, right? What's the limit as it's approaching positive or negative infinity? So I'm essentially asking for the end behavior of these graphs. Okay, so if I go back to f of x, they're asking me what is happening to this graph as it's approaching negative infinity, right? So as the x's are getting infinitely smaller, right, so they're getting more negative this way, what is happening to your graph? So you guys can kind of see that it's actually going to approach -2, right? And then same thing with if I'm approaching infinity to the right, right? So going this way, if you guys can kind of see that dashed line, so it's still going to be -2. And then looking at my down here at g of x, so as it's approaching negative infinity, notice it's just going to kind of keep going down this way, right? So it's going to approach negative infinity, and kind of vice versa as my graph is approaching positive infinity, right? It's just going to, if I were to extend that, it was just going to keep going up and up and up, so it's going to approach positive infinity. So what essentially happens is a horizontal, okay, asymptote, or something that we deal with a little bit less is an oblique, okay, or you guys will probably know it as a slant asymptote, and you guys can kind of see that in this graph right here. Right? So in order to give you a little bit more of a formal definition, so a limit at infinity is going to be as x approaches infinity, Okay. Or, remember, x can approach negative infinity. You guys will see why that's important to check both. Okay, the limit approaches, it's going to approach a specific y value as we saw in the f of x graph, or it's going to be unbounded, right, as we saw in the g of x graph. So going back to pre-calculus, you guys remember that when a factor cancels out from a denominator, right, that actually just means that a whole occurs. Okay, now when a factor doesn't cancel out, you guys knew that as a vertical asymptote. Okay, so looking at some examples that you guys have, so we're going to kind of look at this analytically and see if we can determine this limit. Okay, so the first thing I'm going to do is I'm going to go ahead and just factor this out. So the limit as x approaches 4 from the left. So this negative 2x squared minus 2x plus 12 is actually going to turn into x plus 3 and x minus 2. And then my denominator is going to just be, that's a pretty easy factoring, so x minus 4 and x minus 2. So notice what happens. These x minus 2's canceled out, so that is going to be a whole, right? So I'm specifically now looking at, okay, that's 4. Okay, now I know that it's going to have a asymptote at 4, right? And I know that because if I plug in 4 right here, it's going to have vertical asymptote. If I plug in a 4 right there, it's going to give me 0, which is dead giveaway. It's going to be an asymptote. So guys, I know it's going to be unbounded. I know it's going to be positive or negative infinity. Okay, so right now my job is to decide, is it positive or negative infinity? And this is where I'm going to look at, okay, which side is it approaching from? That's really important. And again, we're going to kind of look at this analytically. So if I'm approaching 4 from the left, I'm going to pick a number that's a little bit smaller than 4 because I'm approaching from the left, and I'm going to kind of see what happens. Now remember, the only thing I'm really trying to figure out is the sign. I already know the answer is going to be infinity. I just got to decide, is it positive or negative infinity? So if I plug in, I don't know, let's just say 3.9. Okay, so again, something less than 4. You can do 3.95. It doesn't really matter. If I plug in 3.9 and I add 3 to it and I multiply by 2 or by negative 2, I'm going to have a negative numerator. And think about it, if I do anything less than 4 minus 4, I'm going to have a negative, right? So a negative divided by a negative is positive. And that is how I know my answer is going to be positive infinity. Okay, you don't necessarily have to write the plus. When you write infinity, it's understood it's positive, but I'm just showing it out for the point. Okay, so let's look at B. Okay, so now I'm going to look at the same limit, okay, but I'm looking at it from the right. Okay, so I'm going to go ahead and just use what we've already done. There's no reason to refactor it. I'm going to look at the limit as x approaches 4 from the right. Okay, again, after I canceled out what I need to cancel and I factored, I have 2x plus 3 and x minus 4. Again, I know that x minus 4 is going to be a vertical asymptote. So now I'm looking at something a little bit greater than 4 because, again, I'm approaching this 4 from the right. And so I'm going to just pick 4.1. Okay, you want to pick something close, and you can even kind of reason through it without really even having a set number in mind. But when you think about it, again, when I plug in 4.1 plus 3 multiplied by that negative 2, it's going to automatically make that numerator negative. And when I plug in 4.1 in the denominator, no matter what I plug in, whether it's 4.00001 minus 4, it's always going to give me a positive number. So notice in this case, my just going to be negative infinity. All right, you guys try number or C on your own. Just pause it for a quick minute and see if you can tell me what you think it is. All right, so let's look at this one. So again, I'm looking at this. The first thing I'm going to do is you can try to factor out x squared plus or minus 2x plus 5, but it's not really going to cancel anything out. So I'm just going to leave it as is. It's not going to change your answer. what you do know is that 1 is a vertical asymptote. And again, you know that because if you plug in 1 into here, right, it's going to give you a 0. It's not going to cancel out with anything up top, so it's not a hole. It is a vertical asymptote. So I specifically need to look at the direction. Okay. So in this case, I'm approaching 1 from the left, so I'm just going to pick something that's a little bit smaller, right? So for example, if my x is 0.9, I'm trying to decide what will my f of x be. Again, this only going to give me the sign of my infinity because I know it's infinity because it's a vertical asymptote. So if I plug in 0.9, okay, that's actually going to give me a positive numerator because if you guys think about it, this squared minus plus the 5, it's not going to kind of override that 5, right? So this is going to be positive. And if I plug in 0.9, so 2 times anything smaller than 2 is going to give me, in this case, like 0.18, right? In case if you plug in 0.5, it's going to give you something essentially less than 2. So when you subtract that 2, it's going to be negative. And so I know the answer is going to be negative infinity. So to give you some formal definitions, okay, and justifications of vertical asymptotes. So kind of to give it more advanced math, if you're going to have something a non-zero over 0, right, then you know that that's going to be a vertical asymptote. Okay, now if you have 0 over 0, again, when those quote-unquote cross out, right, then that's going to be location of a hole. Now, again, we're going to all about this unit especially, guys, is kind of taking what you already know, but the AP test is very particular on the verbiage and the way you kind of justify things. So remember, in order for something, right, or your justification for a vertical asymptote is if the limit as x approaches c, now remember, this could be c from the left or as it approaches c from the right, right, of f of x, it has to be either positive or negative infinity. Right? So if the limit, right, as x approaches whatever c, from the left or from the right, if it's positive or negative infinity, then x equals c is a vertical asymptote. I want to stress this as well. Remember, your vertical asymptote is not a number, it is an equation of a line, right? So if you tell me the vertical asymptote is 4, not so much, it's x equals 4, because again, remember, it is a vertical asymptote, right? So we want to show that as a graph. Okay, so this is a way that you might see it kind of worded, and again, you want to make sure that we use correct mathematical language and correct notation. So the first thing I'm going to do is, again, I'm going to factor these. Okay, so your 2x squared plus 9x minus 5 is going to factor to 2x minus 1 and x plus 5. Okay, that denominator is going to factor into x plus 5 and x minus 2. And again, guys, if you're struggling with factoring these, I suggest you go back and review over that video to make sure that we can factor these out solid. So remember, your x plus 5 is going to be your location of a hole. So we know we're going to have a hole at negative 5. So what I'm left with right now is 2x minus 1 and x minus 2. Okay, so I know that there's going to be a vertical asymptote at x minus 2. So the question is, what is that vertical asymptote? Meaning, what is happening at x equals 2, right? Or is the limit as x approaches 2? So I'm going to check both sides. And guys, it's important because everybody always remembers to check from one side, but we don't remember to check from the other. So I need to know what's happening as x approaches 2 from the left, okay, of 2x minus 1 and x minus 2, okay, and then the limit as x approaches 2 from the right of 2x minus 1x over 2. So again, think about this way. So if I make my little chart, Okay, so 2 from the left means something a little bit less than 2. So again, I'm just going to go with that standard 1.9. So think about what's happening if you plug in 1.9 into this, right? So 1.9 times 2 minus 1, that's still going to give you a positive number. And then 1.9 minus 2 is going to be a negative number, right? Anything less than 2 minus 2 is going to be negative. So I know that that is going to be negative infinity. Okay, and then as it's approaching from the right, so something a little bit bigger than 2. So if you plug in 2.1 times 2 minus 1, still positive, and then 2.1 minus 2 is still positive, right? So if they're asking you to justify that there is a vertical asymptote, it's not enough to leave this and be like, oh, because when you plug in 2, you get 0. That's not correct. This is your justification. Okay, because remember our definition for a vertical asymptote is that as it's approaching C, it has to go to positive or negative infinity from the left or the right. So this is your justification for those.